Hello friends, this is a operating system class. In previous class we have seen that the hardware solution of the critical section problem. Now today we will see the synchronization tool. The synchronization tool is not dependent on platform and hardware. These are hardware and platform dependent. These synchronization tool are the not hardware and not platform dependent. These are independent to hardware and platform. So there are two types of synchronization tool, semaphore and monitor. In our syllabus there is a semaphore synchronization tool only. So we will learn what is semaphore. The semaphore synchronization tool is a integer value, non-negative integer value, which can be accessed using following functions. So the semaphores are the non-integer value which can be accessed by following function called wait and signal. It is also denoted by P and V function. Wait signal also called degrade or upgrade function. These are the atomic function. Atomic function means that this function can execute fully in one go. These are the atomic function. Means that this function can completely execute in one step. Means that if the these atomic function are executing and preemption happened, then again when it's execute from starting, then it's again execute from starting, not between the code. Okay, these are the atomic function. Okay, now the wait and signal. How the wait and signal codes are written. In wait signal, if the s is equal to 0 or less than 0, then s minus. Here s is equal to less than or equal to 0, means that if the value of s is 0 or less than 0, then it is execute the while loop or stuck in the while loop. If while condition is true, then it is stuck into the while loop. If the value of s is greater than or equal to 0, then s minus decrement the s by 1. Then here signal function code s plus plus, it increases the value of s by 1. Here the wait s can't be successfully if s is equal to 0. If s is equal to 0, then what happens? If s is equal to 0, then it is stuck into the while loop. So can't successful. Now the type of semaphore. There are two types of semaphore, binary semaphore and counting semaphore. The binary semaphore's value either become 0, either become 1. But for counting semaphore, the value of value of counting semaphore give the range from 0 to 0, 1, 2, 3, 4, 0 to some value, some finite value. So here the binary semaphore, we can have value of 0, either 0 or 1. But in counting semaphore, the value can be from 0 to some finite value, some finite values. It is used to implement solution of critical section problem with the multiple process. It is used to control the resource that has multiple instance. So the counting semaphore is used to control where the resource that have multiple instance, right? And binary semaphore, it is used to implement the solution of critical section problem with multiple process and the process having multiple instance. Okay, here the binary semaphore is used where the multiple process, and counting semaphore is used where resource have multiple instance. The binary semaphore s is equal to 1. Signal successful, completes yes if the value of binary semaphore is s is equal to 1. and we try to use signal. What signal will do? Signal increment the value of s. So the status of the function successful, and return the value of s remains same 1, because it is a binary Semaphore vary. So the value not be more than 1, 0 or 1. The value is already 1. So when you use signal, the value can't increment, but the function perform successfully. In the binary Semaphore, if s is equal to 0, and apply weight function decrement the value of s. Here the function not successfully complete. It is stuck into the infinite while loop. When s is equal to 0. Okay. Now the critical section solution of critical section. Okay. So here is a while loop, while true, then process p0 enter into the function to execute the critical section. Here we applied wait to the intersection of the critical section and the signal the exit section of the critical section. When any process wants to try into the critical section, then it execute the wait function. Okay. And when after completion of critical section, the process executes signal function. Okay. So here's one question. Here the counting semaphore S is initialized with the value of 2. Okay, counting semaphore where the value of counting semaphore is value initialized with 0, so 2. If there are 4 process P1, P2, P3 and P4, the maximum number of process which can be in critical section together if all process running the following code. This question want the maximum value of the process together in the critical section. How many process together is in critical section? So let's look here. When the value of semaphore is 2, okay, one process comes and execute wait. When wait, the critical section value become 1 because wait decrement value of by 1. So here the process is in critical section. Now another process come and execute wait function. When the wait function execute, the value of s become 0 and the process is in critical section. Now if the another process want to try to enter, so they execute the wait semaphore. The value of semaphore is 0. If the value of semaphore is 0, the process is stuck into the while loop. So at a time only 2 process can enter into the critical section. Understood? Okay. These are some more questions. You can try it. Okay. Here are the terms called busy waiting or spin lock. A process is busy in execution on the CPU but still waiting for the critical section. CPU is wasting CPU time. Here the problem of busy waiting means that, let's see, when the process wants to try to enter the critical section, they comes and execute wait function. When they execute wait function, it is stuck into the while loop. In while loop, the process is executing by the CPU. While loop means that again and again checking the conditions and again checking the conditions and stuck into the while loop. Okay, so when the process is in while loop, the process is in while loop. They using the CPU. they using the CPU. They take the CPU, so they use the CPU is based on the CPU time, CPU computation time. They utilize the CPU computation time. So the blocked processor or the stuck processor are using CPU, in stuck state. So this type of conditions called busy waiting. To overcome this condition, we should have the solution to block that process which is in infinite loop. We will block that process which is in infinite loop. They can't use the CPU computation time. We should add the block statement. We should have the block statement to block that process which are in infinite loop. So they can't use the CPU computation time. So they can't utilize the CPU. So we have do some modification in semaphore. So there is a wait semaphore. When the value is of s is greater than, then it's okay. When the value of s is less than 0, then the process goes into block state. Okay. Now the modification in signal, when the value of semaphore is greater than 1, if the value of s is less than or equal to 0, remove that process P from the queue. This is used to remove this. Where here wait semaphore block the process, and here the signal function wake the process. After waking the process comes into the ready state and execute. After ready state goes to running state. Okay, here when the process in infinite loop wait section blocked it, the process goes to block state. When the execution of critical section completed by other process, then they signal to the blocked process. So blocked process come into the ready state and then go to the running state to execute the critical section. Okay friends, here the synchronization tools topic has been completed. We will meet tomorrow with a new topic. Thank you.